Hello, everyone. Welcome to this video. My name is Alex. I'm a master's student in business analytics and a big sports fan. And today I'm going to be covering part one of a two-part video series on NBA stats data analytics project here in Python. So in part two, I'll be analyzing the data. But first, here in part one, we're going to have to scrape the data. So without further ado, let's get started. So these are going to be our packages for scraping. So we have pandas for our data frame. Requests is what we're going to use to scrape. This is just a setting so that we can see all of our columns in a wide data frame. And then we're going to be using time and NumPy to create a bit of a lag when we put our scraping code into a for loop, but we'll get to that in a few minutes. So let's take a look at the format we can use with requests to scrape data. So it's going to look like this. So R equals requests.get. And the one mandatory argument is a URL. Then we want it in a JSON format, which we can then manipulate to pull into a data frame. So let's get the URL here for this input. So I'm going to be going on nba.com/stats for our data. And the table I'm going to use is under leaders here and official leaders. Okay, so this table here. And so if we take a quick look at the URL up here, you can watch how it changes when we play around with these inputs here. So totals, we get a little per mode argument. We toggle between the playoffs and the regular season, same thing. We can switch the season too. So for this case, I don't just want to scrape 1 year's worth of data. So the table here is just going to be data for one player in 1 year in either the regular season or the playoffs. So I want data for both the regular season and playoffs, and I want to go back, we'll say 10 years. This season has just barely started, so we'll go back to 12-13. So this is a URL obviously right here, but if we just copy paste that into here, we're going to get an error because we need, not just any regular URL, but we need an API in order to actually access the data. The way you can do that is first just right click anywhere on your page here. And this is going to look different depending on your browser and your operating system, but the concept should still be the same. And I'm going to click inspect. This page up here is going to pop up on the side of your browser. And click on network. Make sure you have this fetch/XHR selected. Let's reload the page so that these requests start to populate down here. That looks good. And just kind of click on these and go over to preview and see what these look like here. So you can start scrolling through these and get an idea for just how much information is actually on this one page. But we need to find the one that has our data. And you can use this little preview to figure that out. So I think it's going to be this one here, just from experience. And let's check it out. So our parameters and start digging into this nested file. So headers, this looks like our column headers here. That looks good. And then our data should be in here. That looks very promising. So let's check with our table. And that checks out. So this is going to be our API here, our API endpoint. So we can go back up to headers. And here's our request URL for our API. We can just kind of double click on this here to get an idea of what the request package is going to be looking at when we plug in this URL. So we have this one big JSON file with all of our data. And this here is going to be our URL to input here. So let's say, we'll call this first our test URL. And that's going to go right there. And so notice when we want to scrape this data, again, we want to scrape multiple years, multiple season types. So we can come through here and find first the season. So you can see the format it's going to use. So full year and then dash and then the last two characters of the next year. So we can use that to manipulate this URL and scrape multiple data sets in one cell of code. And then over here, we have regular season. And I believe the alternative is just going to be playoffs. So formatting is a little funky there, but that's what we're going to play with to get regular season and playoffs. First, let's actually just see what this JSON file looks like. So run that. And so we need to put this in. Now let's print out R. So we have this JSON file, should be the same thing we have here. And let's see if we can get our column headers here. So it looks like we can go, I believe, into the result set here. So let's crack that open. Get a little bit further into the nest. And I think headers should be the next argument in. Okay, so we have our column headers here. So let's actually just define this quickly as we could call this table headers. And we have a nice list. So now let's see how we can come back and start to manipulate this URL. But I also want to show why I actually picked this data set. So if you're a fan of the NBA and a fan of data, you're probably wondering like why we're not using something like, we go to shooting here and need some of these advanced stats. And it's a very valid point. So the NBA has some really, really cool advanced stats like this that it's available completely for free on the website. So I can go to last season and let's get a nice like shot dashboard here. So you can see shooting numbers by position on the floor, which is incredibly cool. Here's the problem. So that when we go to find our API here, so this is going to be it. Looks like it's good to go. Here's the problem. Double click on it. We get locked out, which is really, really unfortunate because this is some really cool data. And it actually used to be available for scraping, but that has since changed, which again, really unfortunate, but is what it is. But fortunately, some of the less advanced stats are still available. So now let's take a look at our URL here. We can close out of this now, sadly. Okay, so let's just make sure that if we toggle to playoffs, let's go to another year. Let's just see how this URL is going to change. So inspect. Go to network and reload the page. This is going to be it right here. And let's take a look at this URL. So there we go. We got a good idea of our year format. And then the alternative to regular season is just going to be playoffs. So we can close out of this now. Okay, so let's take a closer look at our actual data now. Let's see how we can access that. Let's go back into that results set. And let's see where the data is stored. Okay, I think it's going to be in row set here. Let's take a look. And that is exactly what we want. So let's say, for example, if we take index 0, this should be the first player on the list. And it is Kevin Durant. So that's going to be his player ID, rank, name, team, and then all of his stats for that year. But I think this should already be in a nice data frame format for us. So let's test that out. So let's go pandas.data frame. See what this looks like. Perfect. So it's already in data frame format for us. So super, super convenient. Then actually, let's add in our columns too. So we can say columns equals, we already have this list prepared. And that's perfect. So this is going to be just the basis of our data frame. And so what we're going to want to do is, again, we're scraping 10 years worth of data for both playoffs and regular season. So we're going to manipulate our URL here so that we can just, in a for loop, just stack this data frame on top of itself over and over again until we have all of our data. So let's kind of start building our for loop here, and we can do it kind of from the inside out. So say this is going to be kind of the foundation of our data frame. So if we just call this, just call it temp df1, it's just going to be temporary. And we can run that. And we also want information on the year and the season type, because otherwise, when we start just concatenating these data frames, we're not going to know where the data came from. So we can say temp df1, then year. So I could create new columns for year and season type, or I think actually I want them to be on the left side of the data frame. So I'll do it like this. Temp df2 equals, then we'll create a new data frame and then concatenate on the columns. So pandas dot data frame, then we can create it with a nice dictionary. So we can say year. Then use the list comprehension here. So I think our first year is 2012-13 for I in each instance of our temporary data frame 1. And then we want another column for season type. And this is want that string right there. That's what we're going to be using for the for loop. I know it'll look a little dirty in our data frame now, but we can clean that up later. All we really need to do is just be able to differentiate between regular season and playoffs. So do regular season for I and range. Okay. And let's just print out temp df2. Make sure that looks good, and it does. And now let's bring these two data frames together. So call it temp df3 equals pandas dot concat. And then I want 2 on the left here and 1 on the right. And then we want to concatenate on the columns. So I'm going to pass axis equals 1. Okay, and now we have our full data frame. So we should be ready to build out our for loop now. So let's copy paste this into a new cell. This will be the kind of foundation of our for loop. Actually, let's start fresh. We can delete these data frames. Just so we don't run into any overwriting issues. And then we want to start with a blank data frame also. And so I think we have our table headers. And so we want for our columns, we want year and season type added to that. We call this df calls. Okay, so then we can start off with a brand new data frame, just a blank one. So let's say pandas dot. Actually, let's make sure this runs first before we put it into our for loop cell. So pandas.dataFrame. This is going to be outside of the for loop. We want this to be just blank with column names. So columns equals dataFrame calls. And that's exactly what we want. So that's what we're going to be starting with. And then we're just going to be stacking data on top of itself. So this will be the foundation of our main data frames. This will be df equals that. And now we need lists to iterate through. So say, just season type first. Say season types equals, and this has to be exact in our URL here. So we need that exact text. And then the other one is playoffs. Now we need our years, starting with, nope, not 2012, 13, 2013, 14, and so on. I will just skip ahead here until I have that list all typed out. Okay, so I have my years list here up to this past season. And now let's create our for loop. So let's say for y in years and for s in season types. Then we don't need that. Move these over so it's in the for loop. And now our last step in the for loop is going to be concatenating our blank data frame with our temporary data frame. So let's overwrite df here and say df equals pd.cat. And then we want df and temp df3, and this time we want it concatenating on the index, so this will be axis equal to 0. All right, and now let's write our code to pull in our JSON. So it's going to be r equals requests.get, and then we need a URL. We'll call this API URL, then we're going to have to define that. So let's come back up here and grab this. Now we need to play around with this so that it changes depending on the year and the season type. So let's go in there and find the first. Yeah, so here we go. This is the season here, or the year, I'm sorry. Delete that and say plus y for year. And then season type. Want that exact text. That'll be plus s. So we're concatenating these strings together, and that will become essentially dynamic. One last thing we can pull in here is something called headers. I don't know that we necessarily need it for this, but when you start scraping on like a large scale, like very quickly, especially on nbasestats.com, which nbasestats can be very stingy sometimes with trying to block you and not allow you to scrape on a larger scale like this. So say headers equals, the format's going to be a dictionary, and we can let's see, come to our headers tab here within our, this is our endpoint API, and scroll down to request headers. And this is just my basic understanding of it anyways, is this is to kind of prevent it from thinking you're just a bot. I think the most important arguments in this are going to be the user agent down here. So let's pull that in. And then we need to create a dictionary format here. So make these all strings, comma, string, another comma, and I'll skip ahead until I have all of this done. Okay, so we have our headers dictionary all filled out. Now that is going to go right here. So headers equals headers. And let's see what else we need here. So I could run this as is. Except I need to adjust these arguments here and right here. So this is going to be y here for our for loop. And then this needs to be an s. So we make sure that changes each time through the loop. So the last thing I'm going to do is I want to throw in like a lag time, because NBA stats can be a little stingy with allowing people scraping their data. So one trick I found that I think has helped me in the past here is to actually slow it down. So rather than running the loop immediately, we're going to institute a bit of a lag time after each time we're scraping. So we can do that with the time package. So we can say time dot sleep. And so if we say time dot sleep 20, that means once we get down to this argument in the for loop, to wait 20 seconds. We're essentially delaying it in the hopes that this will allow us to get through 10 times 2, which is 20 times through our for loop. And the other thing I will do, no idea if this helps. This is just me trying to kind of work around NBA stats here, is rather than just inputting a direct number, so 20 seconds, I can say, this is where we're going to use NumPy, and say just lag equals np dot random. So we're going to use a random number rather than the same number each time. Maybe that makes us appear less bot-like, but dot uniform, and then we can pick anywhere from, let's say, we can go anywhere from 5 seconds up to 40 seconds here. Who knows? Who knows how much this works? This is just this is me just trying to make sure this code runs. So high equals 40. And then we can just put this into here. And then the last thing we'll do is just print out our progress. So while this is hopefully running, we can see how much progress we've made and how much we have to go. So in here, we can say print f string. We'll say finished scraping data for and let's put in the year. This would be for like 2012, 2013, and then season. And then we can also say, we'll say how long our wait time is going to be each loop. So print, say dot, 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 waiting lag seconds. And actually, I think this is going to give us a pretty long float. So let's say round this to 1 decimal place. And we can throw in one last print statement here. This will be outside the loop. Say print, so we know when it's done. Say process completed. Actually, let's specify our total runtime as well. So up here, we'll call this, say, begin loop, and that equals time.time. So that meaning the time when we first run this cell, and then our total runtime is going to be, let's see, be time.time, so the time when we get to this point at the end of the for loop, and then minus begin loop. And let's round this as well. could even put this in minutes here because it's going to take a few minutes. It's just based on the lag alone, and who knows if it'll run the first time as well. So say divided by 60. Then let's round it to 2 decimal places. And I think that should work. And let's just go ahead. So our data frame is going to be our actual, the df here is what's going to have our final data. So we can just go ahead and say df dot to Excel. And let's call this, we'll call it NBA player data dot XLSX. And we don't want the index, so index equals false. And I think we should be ready to go. So let's see how this works. Okay, we have an error first. Oops, forgot a plus sign, looks like. That should fix the problem. Okay, so it's not running the first time. Let's see if we pull out our headers here. Let's see if that changes anything. Okay, now we're off. Okay, we're through 2. And I'll go ahead and just skip this here. Hopefully, fingers crossed, it runs. But I'll skip ahead until we have our data. Okay, we are back. And it didn't run the first few times, but persevered, pushed through NBAstats.com's stinginess. And we have all 20 of our data frames stacked on top of each other, just under 7 minutes to run. Why it failed the first several times and then eventually ran, I don't know. My only explanation is, NBA Stats doesn't really want you scraping its data. But nonetheless, we have our data, and that's what counts. And I also have the Excel file here ready to go so that when we go to analyze this data in part 2 of the project, we don't have to rerun this scraping step. So it's a nice checkpoint. And let's take a look at our data frame. So we have all of our columns, year, season type, and then all the table data, all the way down to the 2021-2022 playoffs, 7,293 rows. Now let's take a look at that Excel file. So here's our Excel file, which we're going to be analyzing. We can clean this up here. Not a concern now. That'll be a video or a task for part 2. So that is all I have for you today. That is a tutorial on scraping data from nba.com/stats. And stay tuned for part 2, where we will be analyzing this data. So please leave a like if you enjoyed the video and you learned something new today, and subscribe for more data analytics content in the future. Thanks for watching.